Hi guys, welcome to another physics video. In this case, we're going to see the addition of vectors using the component method. With the component method, that means the rectangular form. Okay, before we continue, well, it is important to mention that vectors can be added or subtracted. Let's say that the real application, well, imagine that we have an object like this one, and this is the floor. Okay, so this object is being pushed by this force, the force 1, but also is being pulled by this force number 2. And because this object is in the floor, well, it will be dragged. Well, there is another force acting in the opposite direction of the motion. This is the direction of the motion. So there is a friction force going this way. So if you see, there are 3 forces. Well, there are more forces, but in this case, well, I'm just going to draw these 3 so you can see them. So we are going to add these forces and find the resultant force. So in this is the real application that we can see in order to know why do we have to add vectors or subtract them. Okay, so I'm going to explain this topic by doing an example. So let's say that I have 3 vectors and those vectors are forces. So the vector number 1 is a force. Force 1 equals 10 newtons at let's say 60 degrees. Okay, the force number 2 equals let's say 15 newtons at 150 degrees. And let's say that I have a third force, and this is let's say that is 13 newtons at 340 degrees. Okay, so there are some things that we are going to find. Number 1, we're going to do the drawing. Okay, number 2, the drawing of these 3 forces. Number 2, we're going to find the resultant force. Number 3, we are going to find the resultant angle. Okay, so during the process of making this problem, I'm going to explain these 2 new concepts over here. So first, we are going to draw these 3 vectors over here. I got the Cartesian plane. Okay. And I have, well, let's fill it with information. Remember, this is X, this is Y, 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So I'm going to locate those vectors in the Cartesian plane. So the force 1 is in the first quadrant. So this is the vector F1. Let's write that this is in this first quadrant, this is in the second quadrant, and this is in the fourth quadrant, because depending on the angles. Okay, the force 2 is something like this. Let's draw it. Force number 2, and the force number 3 will be this one, force number 3. If you want to, well, this is the angle of the force number 1, this is the angle of the force number 2, angle of the force number 2, and this is the angle of the force number 3. Okay, so if you see, remember that all these two forces, they have rectangular components. We have the F1x and the F1y. Remember that every force has two rectangular components. I mean, I'm not going to draw them all, but just remember that F1 has these two rectangular components. F2 has two rectangular components. And F3 has two rectangular components. So this is important because we are going to use the method of using the components method. So the component methods, it has two formulas. It says, the first formula that we are going to use, it says that we are going to find the sum of all forces in X, all of them. Okay, so this will be the rectangular component of the force 1 plus the rectangular component of the force number 2 plus the rectangular component of the force number 3 plus, and so on and so on and so on. So this method can be used with a lot of numbers of forces. So until I hit the rectangular component of the n force, I can use a lot of forces. So this is the first one, and I'm going to write the second one that is going to be the same, but using the vertical component. Okay, so it's going to be the vertical component of the first force, or the force number 1, plus the vertical component of the force number 2, plus the vertical component of the force number 3, plus, and so on and so on and so on. Okay, so this means this symbol over here, sigma, means that I'm going to add all the components, in this case the horizontal components, and also I'm going to add the vertical components. So there are a lot of ways to do this problem. I recommend you to write these two formulas because they are very important. So what I'm going to do is that I'm going to make a little chart with the data that I have in order to find all the answers. So the little chart that I'm going to have is going to be forces. So the forces that I have is F1, that is only the magnitude, 100 newtons. Okay, and remember I told you this is it's going to be a chart. Force number 2, 15, oh, sorry, it's not 100, it's 10 newtons. Okay, force number 2 is 15 newtons. And the force number 3 is going to be 13 newtons. Okay, this is the first column of my chart. The second column is going to be called angle or direction if you wish. And I'm going to call it angle, or the total angle, or the direction. So the angle of the force 1 equals 60 degrees. It's just a chart that I'm going to fill with information. Remember, the angle of this force number 2 is 150. The angle of the third force equals 340. In this case, we are going to use the total angles. It is very important so that you understand that we are going to use the total angle. Maybe in the next video, I'm going to show you why. And then, what else? Okay, so what I'm going to do here is that I'm going to find fx. Fx, remember I'm going to write the formula f times the cosine of the angle. So in this case right here, F1x is going to be 10 newtons, 10 times the cosine of 60. Okay. Next, F2, the rectangular component of x of the second vector, or the vector number 2, is the magnitude, that is 15 newtons times the cosine of 150. And the vector number 3, the rectangular component of that vector, is the magnitude 13 times the cosine of 340. Okay. And below that column, I'm going to write, well, the thing that I need to find. That is going to be the sum of all the rectangular components. Okay. So, okay, I'll be right back in a moment to this operation over here. Let's continue with the last column of the little chart. That is going to be Fy, the rectangle, the vertical component, that is the magnitude times the sine of the angle. Okay, so let's fill it with information. The first one, F1y, equals the magnitude times the sine of the angle. In this case is 60 degrees. And then next, F2y equals the magnitude 15 times the sine of the angle, that is 150. And then F3y, that is the magnitude 13 sine of 340 degrees. Okay. And finally, I'm going to find the sum of the vertical components, the sum. Okay, so this is the chart. In order to do this chart, well, the thing that we are going to find by doing this chart is the sum of the vertical components, this and this. Now, one way to do it is that you can find them, all of them. I mean, and you can write the answer of the vertical, the horizontal component of the force 1, of the force number 2, of the force number 3. Okay, it's up to you, and you can do exactly the same with the vertical component of the force number 1, number 2, and number 3. You can do it, but in this case, I'm going to do them all, and remember, I'm going to add them. I'm going to add them, so I'm going to add this one plus this one plus this one, and the answer, I'm going to write it over here. And also I'm going to write this plus this plus this, and the answer, I'm going to write it over here. Remember that I'm adding all the components. So let's do it in the calculator. Okay, so what I'm going to do, I'm going to add them all. So it's going to be 10 cosine of 60 degrees plus, now this one. If you want to write all the answers independently, you can do it. And in fact, I recommend you to do it. Why I don't do it? Because it's going to take a lot of procedure, and the chart is going to be so long. But you can do it. Plus 15 times the cosine of 150 plus 13 times the cosine of 340. Okay, so I'm gonna hit the equal button, and this is the sum of all the horizontal forces. That is going to be, I'm gonna write just 2 decimals, 4.22 newtons, and I'm gonna write here that is positive. It is very important that you that you understand that is positive. Now, if you see this number over here is an infinite value, so what I'm going to do, I'm going to save this value into a variable of my calculator. If you see, my calculator over here has variables. It has the A, B, C, D, X, Y, and maybe your calculator has more variables. So what I'm going to do, I'm going to press the shift button, and I'm talking about this calculator. If you got this calculator, a calculator like this, the procedure is going to be exactly the same. So I'm going to hit the shift button, and then I'm going to locate the key that says STO, meaning for storage, and I'm going to select a variable. It could be A, B, C, D. I'm going to choose A, and I'm going to press this button. If you see, if you do it correctly, the answer got into A. So if I hit the AC button and I press alpha A and I press equal, I got this answer. I saved this value, infinite value, into a variable, and that variable is A. And I'm going to write here that I saved this value in the memory A. Why do I do this? In order to work with all the numbers. Because if I only work with 4.22, that number is the result is not going to be an exact result. And what I want to do is to work with all the decimals, all of them. Got it? Okay. So this value is in A. Now let's work with this, with the vertical component. So it's going to be 10 times the sine of 60 degrees plus 15 times the sine of 150 plus 13 times the sine of 340. 340. Okay, and I hit the equal button, and it's positive. Okay, before I write it, I'm going to save it into B. Shift STO, and I'm going to press B. Now I got the answer save into B. Well, let's just see if I did all the procedure correctly. Okay, and the previous one, 10 cosine 60, 15 cosine of 150, and 30. Okay, so in order to see the answer, I press alpha B equals, and that's the answer. And I'm gonna write it just with 2 digits. 11.71 newtons. And I'm going to write that this is a positive answer. And with green, I'm gonna say that that value is saved into the memory B. Okay, now let's continue. Fx is positive. The sum of all forces in x is positive, and the sum of all forces in y is positive. So the next thing that I'm going to do, I'm going to draw a Cartesian plane, and I'm going to ask you in which quadrant I have x positive and y positive. Well, that is in the first quadrant. So that means that I'm going to have this is the sum of all forces in x, and this is the sum of all forces in y. And I need to find the resultant force. The resultant force will be the vector, will be the hypotenuse. This is called the resultant force. So if I make the little drawing of the triangle, this will be the resultant force. This is Fx, and this is Fy, the sum of Fx, and this is the sum of Fy. Do you see it? So if I want to find the resultant force, well, that is going to be the hypotenuse. So I'm going to use the formula that I used before. Resultant force equals the square root of the sum of all forces in x squared plus the sum of all forces in y squared. Okay, I know that this formula we already had it, but I'm going to circle it again. So let's do it. The resultant force equals, remember that this is only the magnitude, it will be the square root of, remember that this value over here, I cut it into a. So it will be, in my calculator, it will be a squared plus b squared. Remember, these values, I save them in my calculator. So let's find it. It will be the square root of a, alpha a squared plus alpha b squared. Let's hit the equal button. That is the resultant force. Okay, so I'm gonna write it. I'm not gonna save it into a memory because I don't need it. I'm not gonna do anything beyond. I'm not gonna do an operation with this value, so that's why I'm not going to save it. So it will be 12.45 newtons. Okay, I'm not gonna circle it because that is the only the magnitude. Now let's find the resultant angle. So if you see the resultant angle, this angle over here is in the first quadrant. It's not in the second or the third or the fourth quadrant. So that means that I don't need to add, I don't know, 180 degrees or subtract 360 degrees. So it's directly, that operation is directly. So in order to find the resultant angle, I'm going to use the formula that I already have with a little modification. The resultant angle equals the tangent inverse of the opposite. In this case, this is the opposite. That will be the sum of all forces in y over the adjacent, that it will be the sum of all forces in x. Okay, I do this and I circle it. I told you I already have this formula, but I'm gonna use it for the resultant angle. And the resultant angle equals, well, it will be tangent inverse of Fy. I got it in B, so in my calculator it will be B over A. So let's do it. Tangent inverse of fraction alpha B over alpha A. Oops. And equal 70. Remember that I'm not going to save it into a memory because I'm not going to use this anymore in another operation. So it will be 70.1639 degrees. So the final answer to this problem will be the resultant force. Remember that the resultant force is the addition of all those three forces. So the resultant force equals, now it's a vector, 12.45 newtons at 70.1639 degrees. That's the final answer of this problem. So let's see it again. Remember, I got three forces over here. So this is the drawing. I'm going to add them. I'm going to add the horizontal component and the vertical components. Once I do it, I need to locate these two components in a Cartesian plane. In this case, these two were positive. So that means the resultant force is in the first quadrant. So I need to find the resultant force, that is the hypotenuse of a right triangle, and I do it with this formula over here. And in order to find the angle, I'm going to use the formula that I used before. Got it? And in this example, the resultant force was in the first quadrant. I guess in the next video, I'm gonna write another example so you can do it with me, where the resultant force is in another quadrant. Got it? Well, and remember, I use the component method because I use x and y. And very important, I use my calculator and I save these two values, infinite values, into two memories of the calculator. Got it? Well, I hope this video helped you, and stay tuned for more physics video. Bye guys.